Great. So first section we're going to look at is 1.2 and 1.3. We've already done a little bit of stuff in each of these sections. So we're just going to finish up what we have left. And Aileen, did you sign back in?
Yeah.
Okay, perfect. All right, so today we're going to solve equations that have parentheses. What property is going to come up when we have equations with parentheses? Multiplication, yep, that's what we're going to do in this property. We're going to have to do it twice usually, but distributive, yep. So this will require us to use the distributive property. Now, some of the things that I write on the board, you don't have to write down. Okay, and people that were here last week, they know that. So when you have to start writing, I'll let you know. All right, so now we're getting into some stuff we're going to write. What was the acronym that we used? It was 3 letters.
Sam.
SAM, right? So SAM. So we're going to look back in your notes if you need to. If you don't need to, and you remember them, that works too. And we're going to write down our steps. Okay. What does the S stand for? Think about that while I answer the phone. So, the acronym is SAM. What does the S stand for? Lucas?
Simplify.
Nice, simplify. Right? What are the 2 things that you have to do under the simplify step? One of them we never had to do until today. What's the first thing you have to do under simplify?
This.
Yeah, Aileen?
Never mind.
Yeah.
Distribute.
Yeah, we're going to distribute.
That was wrong.
Okay, so distribute really just means multiply, usually a couple times. Now, the way I'm showing it, I'm just showing you 2 things, but technically if you had something like this, that's a distributive property with 3 things. You just do the same thing. 2 times 3, 2 times that, 2 times that. You distribute whatever you have on the outside to everything on the inside. Okay, all the terms. All right, so we do distributive first. Then what's the next thing we do after distributive? But we haven't started moving things from one side to the other yet. And this is one step we had to do this last week. Yeah. Nice, good job. Combine like terms. Now remember, combining like terms has to be on the same side. And this mixed some people up on the test. I think they mixed up combine like terms with the next 2 steps. So if I had something, let's go like this. Okay. Like this. So I'm going to put this right back up. So if you still need to copy something down, you can. But I just need space to show you something else. Let's say you had 2x plus 4 plus 3x equals 12. Okay, combining like terms just means to take what you have and put it together. You're not doing opposite operation. Okay? In a problem like this, the correct thing you want to do is combine a positive 2x and a positive 3x. What do you get if you combine a 2x with 3x?
Do we have to write that?
No, I'm just showing you the mistake some people made. Yep. You get 5x. So this would be the first correct step. 2x plus 3x gives you 5x. Now, this is the mistake that some people made. They went like this. Why is that wrong? Like, when would you do something like that? There is a time you do something like that, but it's not when you combine like terms. You would do that. Yeah, Maya?
Oh, it's wrong because you're not putting them together, because putting them together would be adding them together. That's like taking one of them away from the other.
Okay, so when do you do opposite operation? Like when would you actually minus a 2x? You wouldn't want to do it here. When do you have to do that? Could someone give me an equation that you would have to do that in? You can make up anything you want.
Black light terms.
Where you'd have to minus a 2x from each side.
Okay. Oh wait, 2x plus 5y plus 2y.
Okay, and let's just put equals. You don't have to use 2 letters though. You just stick with 1 letter.
Oh, am I supposed to solve
And yeah, just finish. I just need a little bit more.
on the other side?
Yeah, because we don't have an equation yet. We got to put something on the right.
10? What? No.
So can anybody finish that off so it would be an equation where the next step would be minus 2x from each side? Yeah.
Like 10 and then 3x?
Sure, 10 plus 3x. Why would this be correct here? This is definitely the way you do it. This is not. What's different about the bottom equation? Yeah?
Because the 2x, you subtract it from both sides equal.
Both sides, right? That's the key. When you start moving something across this equal side, right? Pretend like there's a line right there. When stuff goes from one side to the other, you have to do the opposite operation. There's nothing moving from one side to the other right there. It's all together on the same side. So if it's on the same side, just combine it. Don't do the opposite. Okay, a few people did that on the test and got the question wrong. All right, so simplify. We got our 2 steps there, and now we're in the next step of SAM. Yep. Yeah. Yep. What's the A stand for in SAM? Actually, it's two operations. Lucas?
Adding and subtracting.
Yep, we do any of our adding and subtracting. Now, this is from one side to the other. Okay, so this is the step where, yes, now you do the opposite operation. Don't do the opposite operation till you get to steps 2 and 3. All right, and now the last step in SAM, what does the M stand for? Aileen?
Multiply.
Nice. Multiply and divide. All right. So if you have a problem that has multiplication or division, that's always the very last thing we do. So we've gone through all these steps last week. We did them in a lot of detail. Now we're going to have problems that have maybe not all the steps. Okay? Don't think you're going to have to do every step in every problem. Not every problem on this week's test is going to have distributive. Some will, some won't. Okay? All right, so let's look at an example. So, how do we know that that problem has, well, I'll ask you first. Does that problem have distributive property?
No. Yeah.
Yes? Okay, yes. Why? What tells you that there's distributive property here? Yeah.
The parentheses.
Right, you've got the parentheses and you've got something out in the front of it. Perfect. All right. So how about Sophia? Let's go through our steps. So under simplify, we already said we have distributive property, so we got to do that. What am I distributing?
The negative 2,
Yeah.
4,
And that negative, if you want to think of it as a number, it's like the number what?
wait, 1.
Close. I think someone said it earlier. Anyone remember what we said earlier? If it's just a negative, it's really what number? Not a 0. Yep. Negative what? Yep. It's like you're distributing -1. So just because the 1 wasn't there doesn't mean that it's not a number. It still is. So it's a -1. You just usually don't see it written that way. Okay? So we're going to do it here and there. All right. How about Mackenzie? Does that negative do anything to the number 12? No. The 12 is on its own on a separate side. Just going to stay right where it is. So Blake, when I multiply here, what's negative times 4x?
Negative 4x.
Yeah, there's not really a lot you can do. Just kidding. Do you need me to sign it? Yeah. So you got negative times 4x gives you negative 4x. And negative times negative 8 would give you, what's a negative times negative 8? Yeah, if you bring it over, I'll sign it for you. Positive 8, nice. Okay, so that's our first step. So negative times 4x is negative 4x. Negative times negative 8 gives me positive 8. Okay, what is my second step? What's my second step? Maya?
To like add positive 4x to the 4x, negative 4x in the total.
Now, do we have x's on both sides? Joe? No, we don't have x's on both sides. So really, there's nothing we need to do with this negative 4x. If I had x's on both sides, I would say, yep, put them all on the same side. But we don't have x's on both sides. So think back to our next step. We did distributive. We did, well, there are no like terms here. Okay, so no combining like terms. So what do I have left now? I'm in the addition and subtraction step. But I don't want to do anything with the negative 4x. Yeah, you want to take another guess?
Subtract the negative 8 from the positive 8 in the 12.
Yep, we're going to subtract 8 from both sides. Why are we doing the opposite operation? Because we're doing it on each side. Okay? Each side. Positive 8 minus 8. Kayla, what does that for me? What is it? So you have $8, you take away $8. 0, yeah. So that's 0. And now on the left side, I think that's what you were giving me. 12 minus 8 gives me, that's my 4. Okay. How about, Gianna, what's on the right-hand side now? Close. What kind of 4x? Negative. All right, so 4 equals negative 4x. Now I'm down to my last step. Okay. We did addition and subtraction. Now we're in the M part of SAM. Multiplying and dividing. Yeah, go ahead, Adriana. Do you know what we have to do at this step? Aileen, give her a chance. She's not going to learn it if you just give her the answer. Look at the right-hand side. How would you read what's on the right-hand side? Just like if you wanted to, like if I just said, can you just read that to me right there? How do you read that? Start with, well, what number is that? Negative 4. And then what about this? X. And then what are you doing with the two of them? What operation? Are you adding them? Are you subtracting them, multiplying them, or dividing them? Yeah, you're multiplying them. So it's negative 4 times x. Right? So now if we want to get rid of that negative 4, we got to do the opposite operation. We just said we're multiplying, so think of the opposite of multiplying. Yep. Can you tell me what to do there?
Me?
Yeah.
Did you divide?
Yeah, you're going to divide. Yes. So we're going to divide. And what are we going to divide by? Lucas?
4.
Close.
Oh, negative.
Yeah. Whenever you divide by the whole thing that's next to the letter. The negative and the 4. All right. Now, how about Elizabeth on the right? What's negative 4 divided by negative 4?
Wouldn't that be 1?
Yeah, it would be 1. That's why we did it. So we cross it out. And Stephen, what's What's left on the right?
1x.
Yeah, just 1x. If you put the 1x, that's fine. If you put x, that's fine too. And now this is the answer we have to figure out. What's 4 divided by negative 4? Joe? Nice. Negative 1. Now, did it say we had to check the answer?
No.
In the directions? No, it just said solve. So all we had to do was solve.
So would that be one?
That would be the solution. Yep, x equals negative 1.
No, but what if that's the solution?
No, the answer is x equals negative 1. Yep. So x is negative 1. It would be no solution if you got something like this. If all the letters disappeared and you get 2 different numbers here. That's how you know it's a no solution. Okay. So any question on that first one? All right. Let's take a look at example 2. Okay, if you can't read it, it's a little fuzzy. I'll just tell you what it says. It's 8, and then in parentheses, 4 plus 3k minus 7 equals 97. All right. So let's figure out what we got to do here. All right, we'll go through our steps. So think in your head, think of Sam. Okay, under simplify. What's the first thing we got to look for under simplify if we have it?
Distributive.
Nice. You got to look for distributive. Okay. Do we have it? Yeah, we do. Right? We got the parentheses with a number on the outside, so it tells us we got distributive. How about Kelsey? What am I distributing here?
8,
8. And what am I distributing it to?
4,
Yep.
and 3k.
3k. Why not the negative 7?
Because it's not in the parentheses.
It's not in the parentheses. Okay. If the parenthesis was over here and that wasn't there, then I would say, yep, now we're going to distribute it to the negative 7. But the negative 7 is not in parentheses. All right. So now we'll do that. Princess, what's 8 times 4? 32. And now we've got 8 times 3k. Mackenzie, what's 8 times 3k? 24. 24k. So for this step, that's all the work you're going to do. Everything else just gets copied down. Minus 7 equals 97. Okay. Any questions on that first step? Okay, so we did distributive property. Who can tell me the other thing you want to look for under the simplify? You don't always have it.
Combine like.
Right, we got to look for that combine like terms. Do I have like terms on the same side of the equal sign? Yes. Yes, I do. Joe, can you tell me what my like terms are?
Negative 7 and positive 32.
Positive 32 and negative 7. All you do is combine them. Don't do opposite operation. Just combine a positive 32 with a negative 7. Right. So Blake, if I do that, what's 32 minus 7?
25.
Nice. 25. And for this step, that's all you're going to do. Just copy everything else down. 24k, the equals, and the 97. Now, how come I don't add 25 and 24 together?
Because it has a k.
Yeah, because it's got a k, right? Those aren't like terms, right? You can't combine something that has a k with something that doesn't have a k, all right? All right, so now we're down to 2 steps left. We're done with the S, simplify. Okay. Next thing, Jaden, what's the next step after simplify?
Addition.
Addition or subtraction, whatever one we gotta do. How about James? Is there any adding or subtracting there that would help us to get k by itself?
Subtract 25.
Nice. We're gonna subtract 25, and where else?
Subtract 25 and 97.
From the 97. Okay. Leilani, 25 minus 25
Cancels out.
cancels out and gives me
0.
0. It's gone. Okay. Maya, what's still on the left-hand side?
The 24k.
Yep, still got the 24k. 24k. And 97 minus 25.
72.
Let's see, 7 minus 5 gives me 2, 9 minus 2 gives me 7. Nice. Okay, so now we've done adding and subtracting. Olivia, what's the M step in SAM?
Multiply.
Yep, multiply or divide. Okay, either one. Lucas, can you tell me which one I have to do here?
Divide by 4K minus
Okay. Can you tell me again what to divide by?
24.
Yep. So divide 24K by 24. And where else?
72.
72. 24 divided by 24. We cross it out, not because it's 0, but because it's... What's 24 divided by 24? We just got 1. 1. Nice. So now we get K equals...
3.
Yeah, 3. Right? And that one went in nice. Okay? If you get a fraction, don't think you're wrong. Some of the ones in the homework might come out to a fraction. Some of the ones on the test might be a fraction. Right? Just because you get a fraction doesn't mean you're wrong. Okay? But most of the time we try to make the numbers not fractions so it's easier for you guys to work with. Okay? Right. Any question on example 2? All right, let's look at example 3 and see if you guys need me to kind of guide you through it, or maybe you guys can give it a shot on your own. The next one we look at, it's going to be pretty much the same thing we just did, but it's going to have 2 sets of parentheses. All right? Yeah. Yep, just scan your ID, and then just scan, you'll see the little thing up there to scan back. Yep. All right, so let's look at example 3. Okay, it says negative, and then in parentheses, 7p plus 3, and then minus 3, and then in parentheses, p plus 2 equals 61. You know what? You're okay, just go ahead, I gotta add you in. Just because you just transferred, so that's okay. Who can tell me how many distributive properties are in this one? Lucas? 2. Can you tell me what I am distributing in the first one?
Negative.
Yes. And that negative is really like what number?
1.
Yeah, it's like -1. So you're going to do that. Now, what number are you distributing in the second distributive? Stephen?
3.
Close. What goes with it?
Oh, -3.
Yes, the negative goes with it. Anytime you do distributive, if there's a negative with the number, distribute the negative with it. So -3 here and here. Okay, so take a couple minutes and see if you can do the distributive property. And then if you get stuck, I'll try to come help you, but you're going to have some like terms after that. So you're going to have to do distributive property and combine like terms. Yep.
So if you -3 times p would be -3p.
Yep, you're going to have 4 things here when you're done. -3p is one of them. Yep. And then you got 3 others to figure out. So take a couple minutes and just try that. If you get stuck, just call me over and I'll come help you.
I have a question.
Yes.
So in between the 2 parentheses, is it addition?
In between the 2 parentheses?
Yeah. Like once you like distribute both the parentheses, do you like add them? Like add all the numbers, or do you?
It depends when you distribute. If you get a negative term, when you do this times this, it's going to be a negative. If you do this times this and it's a positive, then you would put a plus. Okay? But Maya kind of told us what that one's going to be. So she said it's going to be a -3p. So it's going to be a minus. Yeah.
Can I go to the bathroom?
Yeah. Take a look. Okay. So first thing you want to do, you guys already told me, distribute that negative to each term. So Blake, what do you get when you do negative times 7p?
-7p.
Yep. And then negative times +3? Yeah.
Oh, -3.
-3. Now, Maya already told us the next one. Negative times 3p is -3p. If that came out positive, I would have put a plus right there. Okay, but it didn't. And how about Jayliana, what's negative 3? We did times p. So what's negative 3 times 2?
Negative 6.
Yep, negative 6. Now, on the left-hand side, this time we've got all kinds of simplifying. All right? Can somebody tell me 2 things that I can combine together? And this is on the same side. Yep.
Negative 7p and negative 3p.
Yep. I'm just going to put a box around it. That, you're going to combine with that. And what do you get if you combine the negative 7p with a negative 3p? Yep. Joe? Good. Negative 10p. That takes care of what's in the boxes. Is there anything else on the left-hand side that I can combine?
Negative.
Yeah.
The negative 3 and the negative 6. Remember, this is not opposite operations. You are not moving anything to the right-hand side yet. We're just going to combine what's in the green boxes. Yeah, were you going to tell me what you get?
Negative 9.
Yeah, negative 3 and negative 6 gives you negative 9. Okay, any questions up to that step? Now, simplify is done. You did the distributive, you combine like terms. Do I have p's on both sides of this equation? No, so then I don't need to worry about moving the thing with p. Okay, but I do have things that have to move to the right-hand side. Okay? What do I have to move to the right, Steve? I don't know. Not sure? Anyone helping out? What do we have to move to the right? Joe? You want to move that negative 9. How do you move a negative 9 to the opposite side? You add it. Yep. So we're going to add negative 9 plus 9, gone. You get 0. Negative 10p equals, what's 61 plus 9? What's that going to give me? Yeah, Joe? 70. All right, so we did adding and subtracting. Now we're in the last step. Tristan, what's my last step here? Think about the m in SAM.
Divide negative 10.
Good. Going to divide, and where are you going to do it?
Wait, what?
Where are you going to do that?
Underneath it?
Underneath, can you be specific?
Underneath 70 and negative 10p.
Yes, underneath on both sides. Negative 10 divided by negative 10, gone. Gives you 1p equals, and now what's positive 70 divided by negative 10? Yeah.
Negative 7.
Negative 7. Nice. Okay. Any questions on that? So we tried one that had distributive property on 2 distributive properties on the same side. Let's do our last equation and then we'll finish up with the word problem. This equation has 2 distributive properties, but now there's one on the left, one on the right. It's really not that much different than the last one. So we'll go through it together so we get this one done, and then you guys will get the word problem, and we should have a little time at the end for you to start the homework. Also, if you need to do dividers, I'll give you some of those and let you do those. All right, so Caleb, on the left side, do I have any distributive property? Yeah, of course, right? I got parentheses. What am I distributing on the left?
The negative sign.
And that negative is really like what number, if you wanted to pretend it was a number?
Negative 1.
Yeah, exactly. It's like distributing a negative 1. Right? Here and here. Okay, so we'll do that after. Jaden, do I have distributive on the right?
Yes.
Yeah, right? I got parentheses again. What am I distributing there? What is it?
3.
Positive or negative?
Positive.
Yep, positive 3. Right, so I'll do the left-hand side, then I'll ask for some help with the right. So on the left, negative 1 times 4, negative 4. Negative 1 times negative y. A negative times a negative gives me a positive. All right. Anyone think they can tell me the whole right side? What you get when you distribute everything? Yeah, Elizabeth?
21 plus 6, 5.
Perfect. 3 times 7, 21. 3 times 2 is 6y. All right, so we've done distributive property. Do I have any like terms on the same side of the equal sign? No. I've got a number, and then I got a letter. Nope, can't do anything with those. I've got a number, and then a number with a letter. Nope, can't do anything with those. So there are no like terms on the same side. Now we've got to move stuff from side to side. Okay, so we've got a choice. We can put the y's on the right or the left. And I'll let you guys pick. How about Maya? Do you want to put all the y's on the right, or do you want to put them on the left?
Right.
Okay, we're going to put them on the right. So that means this y, it's going to go right over there. Right? Olivia, how would I move this y to that side?
Isn't, like, even though you can't see, isn't there like a 1 there?
You could pretend like there's a 1 there if you wanted, sure.
So you would multiply, which would be 6.
So think about when we have letters on both sides, we still have to do more adding and subtracting. So the multiplying and dividing is always going to be the very last thing we do. So we want to move that y, but what kind of y is it right now? Positive or negative?
Positive.
Positive. And what would be the opposite of
Negative.
that? Right. So we're going to do negative, which basically that's subtract. Subtract y, subtract y. Okay, because we're moving it to the other side. Okay, y's cancel out. Only thing on the left is negative 4. How about, let's see, I think I've called pretty much everybody. Princess, what's going to be on the right? What doesn't change at all? 21 doesn't change. But how about 6y minus y? 5y. All right. So now we got the y's on the right. We've got 2 steps left. Gianna, if I put my y's on the right, that means I'm going to put numbers without y's on the
Left.
They're going to go on the left. And Stephen, how would you move that 21 over?
Combine the left. So you would subtract 21 from
Yep.
both sides.
So now we're going to subtract 21. So we're not even at the multiply and divide step yet. Okay, we're still adding and subtracting. On the right, now that leaves me with just 5y. And what's negative 4 minus 21? What's that going to be? Think about like if you owed someone $4 and then you owe them 21 more.
So it would be 25, negative 25.
Negative because you owe them, it's like a negative 25. I think of negative sometimes in terms of money as like owing someone money. Right? And Jaliana, what would be my last step?
To divide by 5y on each side.
Divide by what?
5y.
Just the 5. Yep, so just the number that's in front. Divide by 5, divide by 5. And Blake, 5 divided by 5, what happens there?
1.
Yep, perfect. So you get 1, and negative 25 divided by 5 gives me negative 5. Now, what if somebody wrote it like this? Is that okay?
Yeah, it's fine.
It's the same. It doesn't matter. I actually like writing it this way better. But if you put negative 5 equals y, you're going to get full credit for that on the test. Great. Any questions before we look at our last problem? All right, so last problem. All right, so do you guys have the word problem already written? No. So it's not super long, but you just need to copy that. It says, if Jim's age is decreased by 9, and then you take all of that and multiply by 8, the result is 48. Find Jim's age. So I'll give you guys a second to copy that down. And once we go through it, first thing I just want to do is maybe underline or circle important stuff there. Some people use a highlighter, so like if you ever wanted to highlight something, like you could always borrow a highlighter from me on like a test or something. That's also a good strategy when you guys have to take MCAS and math next year. You don't take MCAS this year in math, but next year. Some people use highlighters just to help them out. I think even though you do it on the computer now, they still have a highlighter, just like you would on paper. So you can just still highlight right on the screen. You guys probably did that last year. All right, we don't know Jim's age. Okay, so that's going to be our variable. What would be a good letter to represent Jim? I mean, you could use anything, but yeah, James?
X.
X. Okay, you could use X for Jim's age, you could use J. The only thing I'm kind of careful about is if you had a name that began with an O. I wouldn't use an O because that could look like a 0, but X, J would have been fine there. All right, what's something that's important here? Everybody tell me something in that first sentence that's important. Yeah, Joe?
Age is decreased by 9.
Age, right, decreased. I think that's important. And 9, that's something separate that's important. What else is important there?
The 8 and 48.
Yep, 8. Anytime you have a number, that's usually important. And there's one more word there that's important. Actually, 2. 2 more words that are important. Multiplied. And one more word that's important.
Difference.
So yeah, difference is important, but this word decreased by is basically gonna take care of difference or subtract. But one other word that's important there. Anyone see the other word?
Result.
Nope, not result, but near there.
Where do you see the word sum?
No sum in this one.
Well, what are you saying?
What else?
Some word that's not.
One other word that's really important. Without this word, you wouldn't have an equation.
Age. That's good.
Oh,
Yeah?
Different.
If there are any freshmen who did not attend orientation.
All right, so not difference, we mentioned that. One other word, super important.
Class.
Without this word, you don't have an equation. It's the word that gives you the symbol that means it's equals. Yep, is. Yep, is. Okay, without is, you don't have an equation. Okay, so let's take a look at it. Yep, so just sign out and head to the left. And then go down the stairs.
Does it work?
No, I didn't do it yet.
Is it like that big place with all the glass?
Yep, down there, that's right by the child care where they go outside, yep. All right, Jim's age decreased by 9. What does decrease mean? What operation? Subtraction. So let's start with that. What are we decreasing by 9? Jim's age. What's Jim's age? Well, how did we represent it?
X.
X. Jim's age decreased by 9. Now, it says you take that difference. And this part can be a little tricky, and I would have it worded on the test so you understand what this means. The difference. The whole thing. The whole thing is multiplied by 8. So what would you have to do to multiply this whole thing by 8? What would you need to add in there? Parentheses. The whole difference. Not just the x part, not just the 9 part, but the whole thing. What is that whole thing multiplied by? 8. Now we're at the last part. Is 48. What does is mean? Equals. Equals what goes on the other side?
48.
48. Nice. So now we have our equation, and now we have to solve it. And that's actually easier than some of the ones we did with 2 distributive properties. This one only has 1. Okay. So let's finish it up. How about Jaden? 8 times x gives me how much?
108.
Nice. 8 times negative 9. Okay, if you're not sure, I usually have a calculator.
Negative 72.
But yep, negative 72 equals 48. Okay, two steps left. We did distributive property. I don't see any like terms to combine. So what do I do next, Libby?
You add 72 to itself and then it's 0 so it crosses out. And then you add it to 48 as well.
Perfect. So you add it to both sides. This is gone. 48 plus 72, we probably could do it, but let's just use the calculator to do it quicker. 120. So does that mean Jim's age is 120? No. That's 8 times Jim's age. So now how do I get rid of that 8? And that's my last step. Yeah.
Divide both of them by 8.
Perfect. Divide by 8. Divide by 8. And again, these numbers are a little big, so you would, you'll definitely have a calculator for something like that. We get 15. And that's his age. So you could put 15 years, because that's how old he is, 15 years old. But just make sure you put some kind of label because it's a word problem. Right, so test, not going to have a ton of word problems on it, but there'll probably be 1 or 2.
39.
10 minutes. 10:39. Okay, just a couple quick reminders before I give you guys the homework. Homework tonight is a worksheet. Progress reports close on Friday, so I'll be doing those by the weekend. I'll have those done. Review day on Thursday. The review day, remember you can earn extra points on this week's test. And as I said, the test is on Friday.
Wait, what's the one?
Homework is going to be a worksheet.
Oh, you're gonna do